Right, so we're looking at now EDCO sample paper D on page 251 of the handout. I proved that if OB is equal to OD and angle BOD is equal to alpha, the area of triangle BOD is half x1 squared plus y1 squared times sine alpha. Okay, so what's useful first of all is a sketch of the triangle where OB is equal to OD, and that third side there completes the triangle. The angle between BO and D is alpha, and we have to prove that the area of the triangle is half x1 squared plus y1 squared times sine alpha. Okay, so that's the origin O. B we're going to give x1 y1. Okay, so now the alpha angle is made between DO and OB. So seeing as that sine alpha appears in the question, it'd be sensible to go for the version of area of a triangle, which gives in log tables as half AB sine C. So it's two sides times the sine of the included angle by a half. Okay, in this case we have the area is equal to a half times OB times OD times sine alpha. But seeing as OB is equal to OD, that's the same as saying a half times OB squared sine alpha. Okay, because they're the same length, OB and OD. Then we have to find the length of OB in terms of x1 and y1. Right, so what OB basically is, it's stepping out along the x-axis, the distance x1, and going up the y-axis, the distance y1. Okay, so that triangle I'm going to bring down here now. This is the triangle in the cloud, where this side is called x1 length, y1 length, and so on. There's B. So in that case, OB is equal to, using Pythagoras, OB squared is equal to short squared plus short squared. Okay, now if you put that back into my area of a triangle, so now A area is equal to half times OB squared becomes x1 squared plus y1 squared times sine of alpha. Below in question 4, find the coordinates of P, the point of contact of the tangent 3x minus 4y plus 13 equals 0. To the circle x squared plus y squared plus 6y minus 16 equals 0. Okay, so we have to find coordinates. And because of the point of contact, when we solve between the linear and the quadratic, we'll find only one point of contact. So from the linear we get 3x equals 4y minus 13. That's getting x on its own means x now is equal to 4y minus 13 over 3. Because they both are coefficients, it doesn't matter which you take. We're still going to have a fraction, so we have to deal with that. Now subbing that back in to my circle, I get something squared plus y squared plus 6y minus 16 equals 0. And that something happens to be 4y take 13 over 3. Okay, we're helped here by the fact there's only one mention of x in the circle. Okay, so let's get rid of the brackets first of all. Squaring out, you get 16y squared. 4 by 13 is 52 times 2 is 102 y plus 169 all over 9. 3 squared is 9 plus y squared plus 6y minus 16 equals 0. Now if I multiply across by 9, I should clear my fraction, so that's 16y squared minus 102y plus 169, fraction cleared, plus 9y squared minus 144 . 9y squared plus, sorry, this should be 54y plus 54y and minus 144 equals 0. So adding up the y squareds, I get 25y squareds. Okay, 50y, is it? Yep, minus 50y plus 25 equals 0. Again, I can take out 25, so y squareds minus 2y plus 1 equals 0. And as you'd expect, then that factorizes as y minus 1 squared equals 0. So y now equals 1, which implies from up here that x equals 4 times 1, take 13 over 3, which is going to be minus 3. So P, the point of contact therefore is x is going to be minus 3 and y is going to be 1.